Hello, this is Eric Larson coming to you from Silicon Valley. We've got a new video here. This is about a channel orifice for marble lifting. This is the sixth video in a multi-part series about how to use Fusion. We're creating a marble lifter desktop machine as an example of how to do solid modeling. And we first have to have the formalities to say that Fusion is a trademark of AutoDesk Incorporated. And what I'm going to show you next is a complete design for a simple marble lifter. This has been printed in 3D using PLA material, and it works. It will lift and recycle steel marbles of 5/16 inch diameter. These are small ball bearings. This design has only a single channel of upward movement. So we're going to jump to Fusion and show you what I'm talking about. This is the machine that I'm describing. It's a relatively simple thing. If you turn on the if you turn off the sketches and turn on the joints, go to animated joint relationships, you can see that it turns. The marbles come out the top, slide down this little chute, and go in the bottom. If you turn off the case, you can get a better idea of the spiral. And if you're really astute, you'll note that the spiral is kind of turning in the wrong direction. This would be driving marbles out the bottom. But anyway, it's kind of hard to change the direction of rotation in these animations. So anyway, this is what we're trying to build ultimately. If you look carefully, we have gone through some studies in terms of how to design the case for these machines. Here is a 4-channel case, and if you put the spiral in the center, you can put the marbles up these channels, which are on the sides. If you look here at this is a 3-channel machine, which has the inlet in the sides. And the thing that we're really concerned about in this video is how to design this inlet portion. And it's somewhat complicated to design. So let's jump back to our slides and talk about this channel orifice. So in order to lift the marbles, we need to get them into position so that the spiral element can lift them. The opening where the marbles enter is one of the most critical elements of marble lifter design. We're going to talk about how to design this part of it. Target audience is someone who understands Fusion. We expect that you know how to sketch, extrude, and sweep in order to understand what we're doing in the video. And again, like the previous video, the suggestion is that you watch it without focusing too much on the keystrokes. Try to get the general concept, then maybe watch it again and try to replicate the design using your own copy of Fusion. Okay, so the requirements. Marbles have to get delivered into the channel in a downward sloping trough or tube. The downward slope assures that if a marble gets where the spiral element is blocking entrance, it will roll into position as soon as the spiral rotates a little bit further. And the marbles must get delivered into a position in the channel such that they will get lifted as the spiral rotates. So the inlet must be high enough up that the main part of the spiral is used. If the inlet is too low, the bottom part of the spiral will cause difficulty because it's just, we want to get into the really clean part of the spiral without having to think at all about the bottom. So my example for this video is going to be a single channel machine, just to make it as simple as possible. And we're going to make two planes. One plane will have the circular profile of the downward sloping tube. This will be an offset plane relative to one of the cardinal planes. Another plane will have a path for the sweep operation. We will sweep the tube profile along the path. Sweep is intended to stop when it reaches the existing cylindrical body. This will be a tangent plane. It is tangent to the body of our cylindrical enclosure for the spiral. Once the sweep is done, we extrude cut to clear out anything that interferes with the spiral element inside the case. And we'll do another sweep to cut out the inside of the channel orifice. So, okay, let's jump back into Fusion. We will create a new design, and we will look here at the XZ plane. We will sketch on it, create a circle. This will have diameter of 21 millimeters. Okay, and then we will create another circle, which is right on the top here, and this will have, if I hit D for dimension, this one will have 8 millimeter diameter, and we get that 8 millimeter diameter because our marbles are 7.9 millimeters, so they should fit right inside this channel. We'll trim up the bottom part of this circle. We'll trim this up. Okay, then we will then create an offset around these elements. This offset will be 3. We hit enter, finish the sketch, go to our home, select the profile, hit E for extrude. We will create a new body. Okay, all right. We should be. Okay, all right. Okay, here's our profile. Okay, good. We will extrude this to 40. Okay. Now, if we go to our home, we can see that we've created the case. Now, what we will do is orbit around, hit escape, select this face, and construct a tangent plane. Okay, we will say that's at 0. That's cool. We see that it shows up here. We will name this as tangent plane for path. Okay, it's selected. You can draw on it, and we will make some lines on here. The first one comes from top to bottom. Hit enter, select it, right click. This is a construction line. There'll be another construction line which goes from left to right. Hit enter. This is also a construction line. Okay. And then we will make an actual line which starts at the intersection of those two. Hit enter, D for dimension, and we want a 30-degree angle between those things. We hit enter, D for dimension, and we want this one to be 10 millimeters off the bottom. Okay, finish our sketch. Okay, now we will create another offset plane. This one will be offset relative to the YZ plane. Construct offset plane, and we know that this plane will be at offset 12. Okay, so it's just sticking a little bit out past the radius of the side of our thing. We will name this to be offset plane for profile. Okay. Okay, it's selected. We can create a sketch on that. Okay, in this case, we're going to create a 2-point circle. One edge will be here. Hit enter. D for dimension. This dimension will be 12. We'll create another circle which is concentric. Okay, again, D for dimension. This one we want to be 10. Okay, so these two circles are concentric. The edge is aligned with the edge of our channel. Okay, back to home. Now, if we zoom in and we select the profile that is created by these two things. Okay, we want the profile. There we go. There's our profile. And now if we pull down Create, Sweep, okay, our path will be this thing. We don't want to cut. We want to create a new body. And we'll say OK. Now if we go back to home and orbit around, you can see that we created a new body, and it somewhat intrudes into the interior of our cavity. Now we don't want that because that's where our spiral is going to lift. So we've got our first sketch, which we will rename to be Base Feature Sketch. Okay, that's visible. If we select this profile, E for Extrude. I didn't want that. Come on, get rid of this. Okay, E for... Come on, okay, come on, Microsoft. Okay, E for Extrude. Okay, we want to say that this will be a cut operation. We want to come all the way up, and we'll say we'll cut to 40. We'll cut out anything that's on the inside of our object. Okay, we can turn off visibility of this sketch. But now the problem is that there's not really a hole for the balls to pass through. So what do? We'll go back around. Okay, hit Escape to get out of the orbit function. Okay, this sketch is our path sketch, and this sketch is our profile sketch. So if we click on it again, we can rename it. Okay, we turn it on. Turn on visibility for that sketch. Okay, now if we click on the interior part of that profile, and do E for Extrude and say Cut. Oh, we actually don't want to extrude. We want to select that profile, and we want to do a sweep cut. So here's our profile sketch. There we go. Okay. Now if we do a sweep, and what we want to do in this case, instead of new body, is we want to cut, and we want to cut out the inside. Okay, we hit Escape to get rid of that. We turn on our path. Okay, where is our path? We click here, and we click here. Cool. That should give us a cut down the inside of our channel. Okay, turn off the sketches, and let's look at orbit. Okay, hit Escape. Let's go back to home. Okay, let's look at orbit. Okay, if we look in from here, we can see that we're cut all the way through. We don't have any extra stuff in the center, and everything is pretty good. Okay, let's look at our bodies. Okay, body 1. This is our case. We'll name that case, and this thing is going to be our inlet. Okay, we select the inlet is selected. If we do right click, say Appearance, and we will choose some of our favorites. Okay, arrow down. Let's say that we want to make this thing red. Okay, and we'll make the case green. Okay, that's pretty cool. Now we can kind of get a little close this appearance. Back to home, and we can see now that we've got about what we want. Okay, if we orbit, we can see that we're cut all the way through. We don't have any extra stuff in the interior. And if we look from this side, we can see that we have a nice sloping entrance for our marbles to roll in and hit our spiral lifter. Okay, I'm going to hit the Save button. I'm going to say that this is study H because we've done a number of studies already to practice for this for this video. Okay, well, you can see that we've kind of created about what we want. We're going to jump out of Fusion and jump back to our slideshow and go view slideshow. Okay, here's a recap. So this is obviously a very involved series of operations. We have two planes, profile and a path. We sweep the profile along the path, cut away anything extra. Then we cut away the inside of the tube. So if you have more than one channel, we can use the circular pattern tool to replicate the feature. And I'll show you an example of a 4-channel design. So a better solid modeler than I can probably figure out a smarter way of doing this. But let me see if I can find our the example of the four channel lifting solution here. Oh, okay, here we go. Here's an example of the same machine, and we use the circular pattern tool to replicate what we did to get 4 channels. We can orbit this and see that we have a 4-channel machine that will lift 4 balls at the same time. And we simply use circular pattern on what we had before in order to achieve this. Okay, well, that's about all you get.